Okay, my final Mars story is a quick update on the Maven mission, the Mars Atmosphere and Volatile Evolution mission. Maven arrived at Mars in September of last year, and it's an orbiter that is in a very elliptical orbit, so it goes out to, I think it's about 10,000 kilometers or so at the high point, and then it dips down to within a few hundred kilometers of the surface. So it flies through the sort of the space environment where it gets out into the solar wind and can measure that and can measure the charged particles. And when it's close, it's looking at the species that are coming out of the atmosphere, the molecular composition of the stuff that's being lost from the top of the atmosphere. And one of the main purposes of this mission was to examine how the atmosphere of Mars has been evolving since the beginning. And there's been a lot of theoretical work on sort of modeling how the Martian atmosphere has gotten so thin over the eons. And the leading theory was that the solar wind actually strips the atmosphere away. Mars does not have a magnetic field, and so it doesn't have a magnetosphere around it like the Earth does, and so the solar wind can actually interact directly with the planet, and you get these charged particles streaming in at a couple million miles, or a couple million kilometers per hour, and that strips away, carries away some of the molecules from the upper atmosphere. And so there was a press conference the week before last where they've released some of their best observations so far. And this is one image. So the sun would be this way, the solar wind is flowing toward Mars, and what you see is this bow shock in front, which is what you'd expect. The same thing happens at the Earth, just farther away because of the magnetic field. But the way to look at this is the normal density of the solar wind, and when you get into this bow shock, it's about twice as dense as what it is on the outside. And then behind the planet, you sort of get this shadow zone. But the thing to note is that this bow shock actually comes down very, very near the surface of Mars. And so that actually can cause charged particles reaching the surface. And that's another sort of environmental thing we're going to have to worry about if and when we send people to Mars, because the radiation environment is going to be quite harsh. So that's the one thing that they've definitely confirmed. This was expected based on theory. The other thing is, this is a very conceptualized view, but here's the sun, the solar wind streams out, and when it hits Mars, these are the molecules being lost from the Martian atmosphere. And I think there's an animation here which shows how this works. So here's Mars, here's the solar wind streaming in. This is that bow shock we talked about. And then if you look at the material that is being lost, first of all, there's a tail that sort of goes down solar wind, and then there's a plume coming off of much denser material, or much higher quantity of material coming off, and then behind the planet there's sort of this just sort of a bubble of material that gets blown downwind. The numbers they're putting on this is about 3/4 of the material being lost is in this tail that comes off. About 25% is coming off in that plume, and a very small percentage is coming off in that sort of that bubble behind it. And the numbers they're attaching to this is Mars is losing about 100 grams of atmosphere per second. And so that's like a Big Mac per second, if you want to think of it that way. And that doesn't sound like a whole lot for a whole planet, but you average that or accumulate that over several billion years, and that can certainly explain the atmospheric loss that we've seen, where we've gone from a much denser, warm, wet atmosphere early on, where things like Gale Crater were being filled with water, to the current state where the atmosphere is so thin that that you cannot sustain liquid water at all. And so that's it's very nice results. This was what they intended to do. By no means is the mission over, and these are still, this is sort of the low-hanging fruit of what's come back so far. So we expect to hear a lot more details over the next year. Okay, so let's zoom out to the outer solar system and just give you a quick update on the latest data coming back from New Horizons. So the flyby of Pluto was in late July, and they've been dribbling the data back since then, and it's going to continue transmitting for, I think it's until September of next year is when they expect to have most of the data returned. And so one of the things that well, let's just put it in context. This is the global view of Pluto that was assembled shortly after the flyby. And the main thing to note is this so-called heart of Pluto. It's called Sputnik Planum, which certainly looks very different than the surroundings. And at this point, they've been busily counting craters that they've seen in the higher resolution data. So each of these little yellow spots is a crater. And the thing to notice is you don't see a whole lot of them in Sputnik Planum. And what that says is that there's a variety of ages of the surface here. The standard way we date surfaces, unless you have samples that you could measure the radioisotopes in, is the older a surface is, the more densely cratered it is. And so, craters accumulate with time. If you've done something to cover the surface up or alter the surface, then you potentially erase the craters. And so what that says is this area is much younger than the surroundings, that there's some process that has erased the craters here or covered them up or eroded them or whatever, but that indicates active processes going on that would make that area resurface itself. And so this is just a family portrait, if you will, of Pluto and Charon, and they're getting lots of good data back on Charon as well. But there's 4 other smaller moons of Pluto, Styx, Nix, Kerberos, and Hydra, and they're here with Charon to scale. And so all of these were discovered with the Hubble Space Telescope, and they basically were not known when the spacecraft was launched 10 years ago. So here's the best views so far of them. And the one thing that they're talking about now is that at least these two look potentially like they're 2 or more objects that are stuck together. And so what that could indicate that there were many more moons in the vicinity, or small bodies in the vicinity of Pluto. And over the eons, they've collided, and some of them have stuck, some of them have destroyed themselves and been lost. But anyway, that's an early set of observations that is getting some attention. And the other thing that's interesting is looking at the orbits and the rotation periods of these smaller satellites. And so Pluto and Charon are tidally locked, where the orbital period of Charon is the same as its rotation period. And so it's the same as the Earth and the Earth's moon and most of the other sizable moons in the solar system are all locked that way. But you see these four, and it turns out that they're very different. They're spinning fairly chaotically, and they're certainly not tidally locked. And so so Styx is rotating about 3 times for every 6 orbits, and so on with all of these. If you see a movie, they're just each one of them is sort of rocking around and obviously not the same point facing Pluto and Charon. So that's an observation that had not been possible before we got close. And this was another exciting result. This is one of the closer up, or the highest resolution images from the closest approach phase of the mission. And this is about a 35 kilometer diameter hole here, and lots of sort of wrinkles around this. And when they look at the topography, this is called right Mons. It's about 3 kilometers or so high, and this is consistent with a volcano, the topography that they're seeing. And so what they're calling this is good evidence for ice volcanism on Pluto. Pluto, what passes for rock is water ice, and then we've got nitrogen and methane ices as well, and those are much squishier and softer. And so it's entirely possible that you've had material erupting out in places where you get weak spots in the water ice crust, and you get an eruption of other material. So let me go back here. That's just something that they were hoping to see, and they've seen 2 of these now. And I don't have an image of this other one, but it's actually larger than right Mons is. So that's another nice set of observations, and I expect things like this are going to keep coming in. It's every week they're releasing new images that have come in over the previous week. So I'd encourage you just to Google New Horizons Pluto images, and you'll get to the web page where these are all posted, and you can follow along over the next several months as the data keeps streaming back. And this is just a nice view of after the close flyby, where they're exiting the Pluto system, and just see a crescent Pluto with light scattering through the atmosphere. Okay, so let's move a little bit closer to home and do an update on the Dawn mission, which has been orbiting Ceres for about the last year or so. And this is just a schematic of the orbital history of Dawn. When it first arrived, they put it in this very high orbit, about 8,400 miles above Ceres. And then they moved down into this survey orbit. They did complete mapping of Ceres from that distance, and then they dropped it down to about 900 miles and did 12 complete mapping cycles. And it's interesting what they did for that, because they're orbiting pole to pole, and of course Ceres is rotating under them, and it would take a couple weeks to do a complete cycle. And so the first one, they're looking straight down, and then the next cycle, they're sort of looking forward in the orbit. The cycle after that, they look backwards, then they look off to the right, off to the left, and then the four corners. And that allows them to come up with really good stereo images because you're seeing the same features from different angles. And so they've got that complete data set in hand. And so I think it was something like the 26th of October, they started the ion engines on Dawn up again, and they're dropping down to the low altitude mapping orbit, which is only 230 miles above the surface. And that'll be their final position, and they'll stay in that orbit for about another year. I think it's September-ish of next year is when they expect to end the mission. And so from that distance, they'll have a resolution on the images and the other instruments about 4 times greater than what they were getting in the high altitude mapping orbit. And so we've talked a lot about these. This is one of the most distinct features on Ceres is this crater with a series of very bright spots in it. And unfortunately, we still don't really know what those are made of or what's causing them. But just wanted to show you the difference in resolution so far. So this was from the, this was from the survey orbit. And that's the resolution you get. This is from the high altitude mapping orbit. So these are the highest resolution views we have so far. And you can see there's really a lot of detail here, where we used to think there were like 3 bright spots. There's actually lots of bright spots. You see some fissures in the surface. You see sort of variations in the density of this bright stuff. There's fissures here. So the arguments are going on fairly vigorously about, is this ice on the surface? Is it some sort of a salt? Is it, who knows what? But from the low altitude mapping orbit, there'll be 4 times higher resolution. And certainly we're going to see much more detail here. And the spectrometers on board should be easily able to discern these individual features and look at them relative to the surroundings and really come up with composition. So I expect we'll be solving this problem, maybe not by January, but certainly they'll be moving in that direction within the next 6 months or so. So the current state of the spacecraft is they're firing the ion engines. They're spiraling lower and lower every day. I think as of today, they're down to something like 600 miles, and they expect by mid-December to be in the final low altitude mapping orbit, and then by the 3rd week in December, they'll start the global mapping from that position. So expect to see a lot more from this mission.